Many, many years ago, when I first started haematology, we used to treat patients with blood cancers and MDS, which is a form of blood cancer, with transplantation, meaning giving stem cells from somebody else. And you know, back in the day, back in the 1960s and 70s when this was first started, it was thought the main thing you were doing was providing new blood-forming cells or stem cells. And we used quite high doses of chemotherapy and radiotherapy to ablate, to destroy the patient's own bone marrow. And this kind of treatment was really reserved for people under the age of typically 35. But over the decades, we've understood that actually you could get a curative benefit from transplant, not just by giving the new blood-forming stem cells, but also by giving a new immunity, a new immune system to that patient. And we recognize that that new immunity may also recognize the patient's cancer as foreign and kill it. So that is called graft. That's the new immune cells going in versus leukemia effect, GVL. And in so doing, we then reduce the doses of chemo and radiotherapy quite appreciably so that older patients could now safely receive a transplant up to the age of 65, for example, sometimes up to 70. You need a functioning immune system from the donor to kill the cancer. And that functioning immune system from the donor may not be that selective. It may not just recognize the cancer as foreign, it may recognize parts of your body that are really very healthy as foreign too. That's graft versus host, or GVH. So it's two sides of a coin. It's a Janus, right? It's a two-faced animal, right? There's a good part, which is graft versus leukemia, and there's a unwelcome part, graft versus host. And so how do you separate the two? How do you accentuate one? How do you make one more pronounced and the other one, which is deleterious, less effective, less of a problem? And the truth is, we don't know how. The truth is, we don't truly understand. Nobody in the world understands what is recognized for GVL to occur and what is recognized for GVHD to occur, and what cells really mediate the two processes, and whether it's the same or different cells. So what we arrive at is a compromise. So we give medicines to try and reduce GVHD, because if we didn't do that, then a patient could become sick. But we accept that we might be reducing GVL as well at the same time. And in fact, just today, I've submitted a large grant, meaning a request for money, to the Wellcome Trust, which is a charitable foundation, to really investigate the mechanisms of GVL. So we're going to take 400 patients who've had a stem cell transplant and really try and understand what triggers GVL, what cells mediate GVL, and why you lose GVL. So that'll be something we want to actively study. And it's going to be part of a program that involves whole genome sequencing that the government has put in place, called Genome England has put that in place. I've got no GVHD. Will I have no GVL? And the sad truth is that I don't know. I mean, I'll be very blunt. I don't know. And we have had patients who have had GVHD and who've been cured. We presume they've had good GVL. We've had patients who've not had GVHD who have been cured. That's important to remember. We've had patients who've had GVHD and their disease has come back. So clearly, the two are not perfectly correlated. The truth is, Russ, as I always keep saying, there's no point worrying about things you can't control.